What lies beyond the orbit of Neptune in the outer reaches of the cosmos? The answer is the Kuiper Belt. It's like a cosmic junkyard and left over from the birth of our solar system. From small planets to comets, here are the top 10 facts that will help us understand this fascinating area. The first key fact about the Kuiper Belt is its location. It is a cold, donut-shaped region of icy objects that circles the outer solar system beyond the orbit of the 8th planet from the Sun, also known as Neptune. The discovery of the region began in 1992 with the identification of the first KBO, called QB1, by astronomers Dave Jewett and Jane Liu. This marked the first concrete evidence of the existence of such a belt. It also confirmed theories proposed by Gerard Kuiper in 1951 and earlier suggestions by Kenneth Edgeworth and Julio Angel Fernandez. Scientists theorized that this belt could be the source of short-period comets, which orbit the Sun in less than 200 years and often originate from this region. These objects have remained largely unchanged since the solar system's formation, offering valuable insights into its history. The second vital fact is its substantial size. It extends from the orbit of Neptune at approximately 30 astronomical units, otherwise known as AU, to around 50 AU from the Sun. This is similar to the asteroid belt, but much larger, containing remnants from the early solar system. The belt is populated by a range of objects, including dwarf planets, comets, and other small celestial bodies, which are all collectively known as Kuiper Belt objects. The largest known object in this belt is Pluto, with a diameter of approximately 2,376 kilometers. Other large KBOs include Eris, Haumea, and Makemake, each measuring over 1,000 kilometers in diameter. Most KBOs are at least 100 kilometers wide, and the smallest detected objects are around 980 meters across. Another fact about this region is that the objects are primarily composed of frozen volatiles such as methane, ammonia, and water ice. The surfaces of some larger KBOs like Pluto and Quora are enriched with more complex compounds. It includes hydrocarbons and nitrogen. This composition suggests that the objects are remnants of the early solar system. They preserve the original materials from which the solar system formed. The fourth fundamental fact is that it is not evenly populated. This contains several distinct regions, including the classical Kuiper Belt, the resonant KBOs, and the scattered disk. The classical Kuiper Belt is further divided into dynamically cold and hot populations based on their orbital characteristics. The scattered disk covers the outside border of the main belt and extends beyond it. It reaches around 1,000 AU from the Sun outward. Objects in the cold classical population have low inclinations of less than 5 degrees and have nearly circular orbits. They orbit the Sun in a more orderly and less disturbed manner. This stability suggests that these objects formed in their current locations and have remained relatively undisturbed. It has a combined mass estimated to be about 1% of Earth's. The hot population consists of objects with higher inclinations greater than 5 degrees and more eccentric orbits, indicating a more chaotic past. The formation history of the hot population is thought to have been influenced by the migration of the giant planets. This planetary migration scattered these objects into their current, more varied orbits. As a result, the hot population includes a broader range of compositions due to their different origins and subsequent mixing processes. It has even less mass, which is approximately 0.03% of Earth's. Neptune's influence is the fifth fact that we have to understand. It exerts a significant influence on this belt by shaping its structure and dynamics in several profound ways. Many objects in it are locked into orbital resonance. These resonant KBOs complete a specific number of orbits in the same amount of time that Neptune completes a specific number of orbits, or in other words, it is known as a ratio. For instance, the 2 to 3 resonance, where objects complete 2 orbits for every 3 of Neptune's, is populated by Pluto and other Plutinos. Its gravitational influence creates gaps in the Kuiper Belt. This is similar to the Kirkwood gaps in the asteroid belt. In certain regions, particularly between 40 and 42 AU from the Sun. The sixth fact is the mass discrepancy of this region. This refers to the significant difference between theoretical predictions and observed mass. Models of the early solar system suggest that the Kuiper Belt should contain about 30 Earth masses of material. but current estimates put its mass at only about 0.01 to 0.1 Earth masses. This concept is puzzling because the lower observed mass is insufficient to account for the formation of large objects like Pluto and Eris. One hypothesis for the missing mass is that the belt once had much more material, but much of it was ejected due to gravitational interactions. As Neptune migrated outward, it could have scattered a significant amount of material into the Oort cloud or out of the solar system entirely. Another theory involves collisional grinding, where large objects in the Kuiper Belt collided and broke into smaller fragments. Many of these were removed by solar radiation pressure and other forces. A seventh interesting fact is Pluto. If you're as old as I am, which isn't that old, it was once considered the 9th planet of our solar system, but now this is the most well-known resident of the Kuiper Belt. Its status changed in 2006 when this was reclassified from a planet to a dwarf planet. Despite this change, it remains an object of significant scientific interest due to its unique characteristics and its location. The dwarf planet is accompanied by 5 known moons: Charon, Styx, Nix, Kerberos, and Hydra. Charon is the largest of these, and its size is so substantial relative to Pluto that the two are often considered a double planet system. The Kuiper Cliff is the 8th fact that shapes our understanding of this region. This phenomenon refers to a sudden drop in the number of small icy objects in this region. It was first observed in the early 2000s and has intrigued astronomers ever since. As a result, the number of objects gradually declines beyond 50 AU, and the drop-off at the Kuiper Cliff is much more abrupt than expected. This sudden decline occurs around 47.8 AU. Several theories have been proposed to explain the Kuiper Cliff. One leading hypothesis is resonant jumping, where objects within the belt experience gravitational interactions. This causes their orbits to become unstable. Over time, these interactions can scatter them into more distant orbits, creating the observed depletion of objects in this region. And last but not least, the 10th fact is about the origin of comets. The Kuiper Belt is a significant source of short-period comets that complete an orbit around the Sun in less than 20 years. When these objects are nudged from their orbits, they can be sent into the inner solar system, becoming active comets. Some of these objects are known as centaurs. They have orbits that lie between those of the giant planets and can be considered transitional objects between KBOs and short-period comets. As they migrate inward, they warm up and develop the characteristic coma and tails of comets due to the sublimation of their icy component. So that's all about the Kuiper Belt. With even stronger telescopes and space explorers, we might just even find crazier stuff out there. What's the most interesting fact you learned about this unique region? Drop it in the comments below, and don't forget to like and subscribe.